Let's go over the notes for section 8.2, integration by parts. And integration by parts is simply a method of integration useful for when two different types of functions are being multiplied together. For instance, if we want to find the integral of a log function multiplied by a polynomial, then this integration by parts formula can be useful. Formula says this: integral of u times dv is equal to u times v minus the integral of v times du. And this formula actually comes from the product rule. It's derived from the product rule that we learned for first semester, product rule for derivatives. And just to show you where that's coming from, if we want to find the derivative of two functions that are being multiplied together, we said the derivative for uv is u prime v plus u times v prime. And if we rewrite this, we can think of this as v times du and think of this as u times dv. If we take the integral of each term, this first term, integral and derivatives, we know are just canceling each other out. That gives us uv. And then we have equal to integral of v du plus integral of u dv. And if we rearrange and solve for integral of u dv, then we're left with uv minus integral of v du. So this is just a way that we can solve a problem by rearranging this product rule and using the product rule to solve these types of problems. So the steps that we're going to take is we're going to first, we're basically looking at the left side of the integral problem, and we're going to have to decide which part goes with which variable, which part goes with u, and which part goes with the dv. So first step is we want to determine the u value, and there's an acronym that shows us the order that we want to go about determining the u value. So there's a preference order with first preference being the logs, followed by inverse trig, followed by polynomial, exponential function, and finally trigonometric function. So if there's a log function, then log function takes precedence, then our u value will be the log function. If we're comparing between log function and exponential function, again, log function is higher up in the preference order, so our u value will be our log function, and then our dv will be the other function. Okay. And then once we have u and dv assigned, then we want to go ahead and find the other variables that's missing, which are du and v. And then we're going to plug into our formula, the right side of this formula, and integrate and solve. Okay, so example 1, let's say we have the integral of x times e to the x dx. So we're going to use the acronym LiPT to determine our priority order. We see that x is polynomial. Actually, we're going to call this polynomial or algebraic. So they all fall under the same category. So if we see 2x plus 1 or x minus 1 or x squared plus 4 or x to the fourth, that all falls under polynomial. So if we have algebraic compared with exponential function, we see that algebraic is higher up in the preference order than exponential function. So we're going to let our u value be x, and we're going to let our dv be e to the x dx. We're just always going to attach dx to whatever is associated with dv. Okay. So our next step is we want to find du and we want to find v. So to get from u to du, we're going to use derivative process. So the derivative for x is 1, and then this is really du over dx, so I'm going to move dx over to the right side, so therefore du is equal to dx. And dv, to get from dv to v, we're going to take the indefinite integral. So when we take the definite integral of both sides, this is like solving a differential equation. dv becomes v, integral of e to the x becomes e to the x. And so now we have all four parts, and we can plug into our formula here. So our formula says u times v minus the integral of v times du. So our u and our v value are x and e to the x. minus the integral of v times du. So that's e to the x times dx. Okay. So we just have to resolve this portion. So this is done. There's nothing else to do here. However, we have the integral of e to the x that we still need to take care of. So we know the indefinite integral for e to the x is simply e to the x. So then we're left with x e to the x minus e to the x plus c. Okay, let's look at example 2. We have the indefinite integral of x times secant tangent of x dx. So we see that there are two different types of functions. We have x, which is representing the, which is an example of algebraic, just like before. Secant tangent, we're going to file this under trig function. So if we're comparing between algebraic and trig, we see that algebraic is higher up in the priority order than trigonometric functions. So again, our u value is x, and our dv is secant tangent dx. To get from u to du, we can find the derivative. So x becomes 1 dx. To get from dv up to v, we're going to have to find the integral. The integral of secant tangent is simply secant, because the derivative for secant is secant tangent. So the integral rule will just be the opposite direction. Okay, so we have all our pieces here, so we can plug in. We have u times v minus the integral of v times du. Okay, this portion is done. Now we just have to take care of integral of secant. And integral of secant, which was learned recently, is natural log of secant plus tangent, okay, plus c. We don't want to forget that there's a minus associated with the integration by parts rule, so we have to include that. Okay, example 3, we have integral of x, natural log of x dx. Now we have x is algebraic, natural log is log function, and if we look at our LiPT preference order, we see that logs comes before polynomial, before algebraic, so our u value has to be natural log of x, which means our dv is equal to x. Okay, so our derivative for natural log is simply 1 over x dx, so that's our du. Integral of dv, go through power rule, so x becomes x squared over 2. So now we can plug into our rule, which is u times v, which is x squared over 2 ln x, u times v, minus the integral of v times du, x squared over 2 times 1 over x dx. Now this portion is done, so we can just leave that alone until we're ready to compile our final solution. This portion we have to do some more work with. The x squared and x, we can cancel out 1x. And we can also, this 2, we can pull the 2 out as 1/2. And then we can find the integral of x, which is simply x squared over 2. Multiplied with 1/2, we get x squared over 4. And so our final indefinite integral will be x squared over 2 natural log of x minus, that's coming from our formula rule, minus, and then we found the integral of 1/2 x dx, which is simply x squared over 4, and then plus c. All right, example 4, we have natural log of x, and then we have dx. So we can think of this as 1 dx, and we can file 1 dx under algebraic, and natural log of x, obviously logs. So that means our u value is natural log of x, and then our dv is simply dx. So again, we find the derivative. Natural log of x becomes 1 over x dx. The integral of dx, we can think of this as the integral of 1 dx. So the integral of 1 is simply x. If we start off with a constant, our integral just means that we're going to attach a variable to that constant. So integral of 1 is x. And then our rule is u times v minus the integral of v times du. So x ln x minus the integral of x times 1 over x dx. The x is canceled out. We're left with integral of 1, which again will produce a variable of x. So finally, we have x ln x minus x plus c.